Welcome dear students. Today we can discuss our IET 2023 actual question paper. So generally we can see that inside them there are good problems and at the same time there are so many doable problems inside that. Okay. So our first question, it is actually a simple problem. Let S is equal to 0, 1 and 1, 2. That means 1 is out from here and not including the 2 and 3 and 4. That the integer values of the given set will not included and external values of t as there. And you can see if you can do that expression as in the form of a set form, it is equal to 0, 1, then 1, 2 and 3, 4. Towards some discrete numbers 1, 2 and 3. There are 4 numbers. Here it is S and that should be t. So this is a problem as actually what? There are infinitely many functions from S to t. It's very simple. You can see 0 to 1 there are infinitely many points. And at the same time 1 to 2 also infinitely many points and the finite count should be that on t. So definitely the map should be more and there are infinitely many from S to t. So it is very simple. So first question is very simple one. And at the same time come to the next confused one. That is, there are infinitely many strictly increasing functions from S to t. That is actually difficult because there are finite count inside them. Then if it is 1, then it is actually you can see this domain is infinite and that should be finite number. It is not possible to make such increasing function inside them. They are steady inside that. This is the situation, so we can see that this is actually wrong. Now the number of continuous function from S to t is at most 120. And at the same time, every continuous function from S to t is differentiable. You know, that's actually very nice. You can see if you identifying an interval and that is actually bounded inside there. So not bounded, that is actually 0 to 1, 1 is excluded from there. So if you map any value from here to any one of the discrete number there, and that should be continuous inside there, then definitely all the domain should be inside there. Now, if you define that number be a constant, when you are differentiating it, it should be what? 0. That means every such values inside them, the derivative, if it is a continuous one, then it is differentiable. That's also correct. So, we come back to the C, option C. How many such number of continuous functions from S to t is at most? You can see these are actually very inside them. Whatever may be the count inside them, we can identifying this 2 or 3 or 4 different values are there. And we can observing these 3 different sets. So, whatever may be the continuous condition inside them, definitely this 3 mapping should be there. That's equal to 4 into 4 into 4 times. This is actually the count inside the continuous function inside them. Then the expression is what? 64. It is given that it is actually from S to t at most 120 is this. Then we can see that is also true. Okay. Now I come to the next problem as t1 and t2 be two distinct common tangent to the ellipse x square by 6 plus y square by 3 equal 1 and y square is equal to 12x. Many different procedures are there. But it is better we can see y is equal to mx plus c be a tangent to y square is equal to 4x, then we can see c is equal to a by m. Here instead of 4x it is given as y square is equal to 12x, then a become 3, so this is 3 by x, 3 by m. This is our c. And if it is in the form y is equal to mx plus c be a tangent to x square by a square plus y square by b square implies the condition for c square is equal to a square m square plus b square. You know that two specified conditions. Now it is very interesting. You know, here c is a by m, that is 3 by m. When you are replacing that to c as 3 by m, that is equal to 9 by m square. And a square is here 6. So 6 m square plus b square is 3. Will provide you the slope of the common tangent. That means you can see this implies 9 is equal to 6m raised to 4 plus 3m square. So dividing by 3, we can see it as 2m raised to 4 plus m square minus 3 is equal to 0. So this is a quadratic in m square. And at the same time, we replace m square is 1, then 2 plus 1 plus, that should be satisfactory. That means one of the root is 1, m square is 1, then other m square is minus 3 by 4. So we can easily observe this one as m square is equal to 1 or minus 3 by 4. But this is not satisfactory because m square is not become negative, non-negative. The reason implies the slope of the common tangent m square is 1 implies m is equal to plus or minus 1. Then c is equal to what? Plus or minus 3. Then what about the formula? Y is equal to plus or minus of x plus 3. Then inside one option, this tangent intersect at x-axis at minus 3, 0 or minus 6, 0. That we can easily observing from here. Put y is equal to 0. Implies x is equal to minus 3. So the point is minus 3, 0. That is actually one option here. At the same time, you want to find the next as depending on the area. So here C is the correct option. Now we come to the area of a quadrilateral A1, A2, A3, A4. That should be 35 or 36. One should be correct. So you just find what is that A1. A1 and A2 are the tangent touches at P. P means our parabola and E means ellipse. So if you draw a common tangent here, then one of them touch here as on the parabola and other should be here. So this is actually A1 and that should be A2. We can see whether it is A1 or A2, no problem. But due to symmetry on x-axis, we can see that tangent again, there's no, the other tangent also again touches here. That's actually what? Other point A4 and A3 or like this. So you want to find this area. Area of this quadrilateral. How to find the quadrilateral? You know, because of the symmetry inside them, this is a vertical line. Due to this minus 3, 0, you can find this equation by point of contact. The chord of contact can be applied. Otherwise, you can see by solving the equation, we can find this equation and that equation. We can see what are the coordinates of A1, A2, etc. You know, this A2 and that A1, x coordinate be same. So that should be the vertical line. And y coordinates also same. How to find it? You can see y is equal to x plus 3. I just take the positive sloped curve. There is minus x, minus 3 is also there. And at the same time, y square is equal to 12x. So we can replace here as x plus 3, the whole square is equal to 12x. Therefore, x square minus 6x plus 9 equals to, I choose that 12x to the left side. It should be x minus 3, the whole square is equal to 0. Then x is equal to 3. Then x is equal to 3, replace here. You got y square is equal to 36. Then y is equal to plus or minus 6. So one point is 3, 6. Then exactly other is minus 6, 3, minus 6. So the same process we can applying that y is equal to s plus 3 here. And also we can solve. It will give you x is equal to minus 2 and 1. You can see. Then the points are in the quadrilateral form like this. This is minus 2, 1 and here it is minus 2, minus 1. And this is 3, 6 and here it is 3, minus 6. So this coordinate is actually minus 2, 0 and this is 3, 0. So this length is what? 5 units. And this distance is what? 2 units. 1 minus 1. And this is actually 6 minus minus 6. That is equal to 12 units. So 12 and the 2 and this distance is 5. So how to find the area of trapezium? Area of trapezium is half h into L1 plus L2. That is 1 by 2 into 5 into, that's the distance between the parallel lines, and 2 plus 12. So it is equal to 5 into 7 or 35. Is also a very simple question. But here in our discussion you can see it is required to find C values of a parabola. That y is ms plus c become a tangent to the parabola, and at the same ellipse you need to find the equation and solve the point, etc. is there. But only 17 questions, too much time to find this. Okay, now I come to the next problem. This. It's actually a beautiful problem inside here. So here a cubic order equation as f of x is equal to x cube by 3 minus x square plus 5 by 9 x and 17 divided by 36. This expression is a cubic one, and you are thinking about the 0, 1 to 0, 1. That is actually 0, 1 is a specific region. You can see this is actually the region inside them. So this is 0 to 1 and this is 0 to 1. So the entire region can be observing as this expression. So the area bounded by that should be 1 unit. And come back to this one. You can see, put x is equal to 0, that is f0. It will become 17 by 36. And when you are replacing 1, that is actually f1. f1 is equal to 1 by 3 minus 1 plus 5 by 9 plus 17 by 36. So we can do it as a minus 2 by 3 plus 5 by 9 plus 17 by 36, or it is equal to 6 minus 1 by 9 plus 17 by 36. So it is 13 by 36. So 17 by 36 and 13 by 36, you can see that two numbers are around x, y axis here. It is equal to, if it is 0, this is actually 17 by 36. And here it is equal to 13 by 36. So this is actually moving up. How to find this number? By simply differentiate and put them to 0. So this we can find f dash x and put them to 0 and solve. We can see it as what? It is actually at x is equal to 1 by 3. So when you think x is equal to 1 and y is equal to 1, here it divide them to region. You can see the region, this region, and I mark the next one also, this region. This. How to find the area under this curve? You can see in the total rectangle is 1 unit. Area under this one, simply we are able to integrate it. We can see integral 0 to 1 x cube by 3 minus x square plus 5 by 9 x plus 17 by 36 into dx. X cube by 3 minus x square plus 5 by 9x plus 17 by 36. So we can integrate. It is equal to x raised to 4 by 12 minus x cube by 3 plus 5x square by 18 plus 17 by 36x 0 to 1. So lower limit is totally becomes 0 and should be 1 by 12 minus 1 by 3 plus 5 by 18 plus 17 by 36. It is equal to 1 minus 4 divided by 12 plus 10 plus 17 divided by 36. That is equal to minus 3 by 12 plus 27 by 36. So 18 by 36 equal 1 by 2. So area below this section, is 1 by 2. So totally it is 1 unit. So this is also what? 1 by 2. This is one of the interesting situation of the problem. So it is a cubic order equation. Area under the curve above x-axis is 1 by 2, and above that curve up to y is equal to 1 is also 1 by 2. And it's a square with unit length is also very important. Now, it is given there is a line which crosses the curve. This line which crosses the curve. You can see this is actually 1 unit. If you are able to draw a line, this, and you can see this section, then area, because of it is 1 unit, it is exactly, if it is a width is k unit, then k into 1k is the area. So that length is very important. But you can see in our question, it is given there is a line which crosses this curve. And I marked as a line LH, where this height is referred as a h unit. That means y coordinate of this line at the point is h and corresponding to this x unit. Now we can see it is very interesting, the region above x axis and below x axis. This line y equal to k. And at the same time, y is greater than f of x and y is less than f of x. These two regions are subdivided into green and red. You can see when the line less than y is f of x, we referred as in the shade red. This section. These two are given as red. And that y greater than, we referred as green. This green, here also green, and here also green. So these are the classifications. So you can see this green region is above this curve and red region is below this curve. Now it is very interesting, this classifications of y, and you are thinking about whether it is exists for h as 1 by 4, 2 by 3, and it is satisfactory with the condition with the different stages. This. There exists an h belongs to 1 by 4, 2 by 3. In all this 4 option, you want to find the value for h. Or you want to show that this should be inside there is an h and satisfactory with the area of a green region above h and equals to the region below that LH. Look this. The problem is this. Option A. I come to the first section. A. Along this line, this region above, that's actually green, and below region is also green. If there are two green regions are equal, then you can see the corresponding h value is inside 1 by 4 and 2 by 3. H belongs to 1 by 4, 2 by 3. You want to search, is it true or not? Right? So I come back to make the measurements as in the form with the different names. This is actually G2 and this region is G1 and that region is G3. So as per the suggestion given to you, the area above that G2 is same as the sum of that G1 plus G2. G1 plus G3. Below portions of a green region and above portions of a green regions are equal. So listen, if you add G2 on both sides, that is G2 plus G2 is equal to G1 plus G2 plus G3, right? Then you can see G1 plus G2 plus G3 is entire region of the green that we already proved as 1 by 2. This is equal to 1 by 2. Then this also what 2G2 is equal to 1 by 2 and which implies that G2 is equal to 1 by 4. That means the entire 1 by 2 is subdivided with this section. That means G2 is equal to 1 by 2, 1 by 4 and G1 plus G2 is also 1 by 4. It is very interesting by observing the problem. Look this, how to divide them? You can see whenever you can observing the expression, that value should be happen only with this portion becomes 0. If it is nullified, then only it is happens. Otherwise, a small portion should be out from that and that should be balanced by these two expressions. This is actually the geometrical observation happened to this problem. look this, whatever it may be this, if you can shift up this, then it is subdivided equally. Because of, you can see, 1 by 4, I think I can explain again the situation here. We already explained there, because of the rectangle inside them, if this region, that's actually our G2. We refer it as G2, and that G2 is equal, this G2 is equal to 1 by 2, 1 by 4 means this height should be what? 1 by 4. Clear? Then the rest of this height is what? 3 by 4. If that G2 is 1 by 4, then H value should be this value should be what? It should be H as 1 by 4. Then only you can see this expression will give you 1 by 4 and that should be, so H is equal to 3 by 4. Then only you can see this one. So basically what? It is out of the given suggested region. What suggested region? H belongs to, given H belongs to 1 by 4, comma 2 by 3, and you can see G2 is 1 by 4, only this region, because of it is a square side as 1 unit, this should be 1 by 4. So the rest of this H should be what? 3 by 4, then only it is feasible. So G2 is equal, G1 plus G2 is feasible only at H is equal 3 by 4, which is beyond the given limit, so it is not correct option. So I come to the next problem, next option. What is the next option? So option A is wrong. Now there exists H belongs to 1 by 4 and 2 by 3 such that area of the red region above LH and area of red region below LH are also equal, same situation. That is R2. You can see our portions are this 2. This is actually R2. I just mark this one is R2 and this is R1. Otherwise it is R1 and that should be R2. Anyway we can put it. These two are equal. You know R1 plus R2 is what? 1 by 2. If they are equal, definitely they are equally 1 by 4. Then you can see this is that graph, and if you draw a line like this region, it is actually 1 by 4 and this is also 1 by 4. You can see how it become 1 by 4. Definitely you can see our f of x is equal to 1. F of 1 is equal to, you can put them and it is 13 by 36. You can initially observe them. Look this number is definitely greater than 1 by 4. So when the graph is moving up to this point is there. And 1 by 4 is just below. And this region is our red region. This is 1 by 4. So definitely because of H is 1 by 4, that value, this height is equal to H is equal to what? 1 by 4. Then only, when H is equal to 1 by 4, then only you can see R2 is also 1 by 4. So again look this, our limit is given as what? 1 by 4 comma 2 by 3 and it is given as closed interval. So definitely it is true. That 1 by 4 will give you R2 is 1 by 4, which is same as that of R1 is also what? 1 by 4. Then only the total becomes 1 by 2. So using the concept of the question, we can easily answer that two questions. First should be wrong and second should be correct. Now third option. Look this. There exists an H belongs to 1 by 4 comma 3 such that area of region above that green region above that LH is equal to the area of region below that L2. Red region below that line L2. You can see the region above that, it is actually our G2. We already put this one as our G2. And at the same time, this is a below portion red as R2. So these two are equal. Look this. I shall draw the figure again. This is the curve and there is a line. This region is our red region and at the same time this region is our required G2. Then you can see this G2 is equal to this R2. I just add this region to the expression. This region. You can see that is actually R1. So I add that R1 bond both. So G2 plus R1 is equal to R2 plus R1. You already know R2 plus R1 is total area below the curve and above x-axis. That should be 1 by 2. What is G2 plus R1 as per the figure? You can see there is an h value here. And totally this up to 1 unit. So this length is what? 1 minus h. So this total region, that is G2 plus R1 is this 1 minus h into width as what? 1 unit. So it is 1 minus h. So 1 minus h is equal to 1 by 2 implies h is equal to 1 by 2. Definitely it belongs to 1 by 4 comma 2 by 3. This is true. So our C option is also true. Now finally, there exists an h again 1 by 4 comma such that red region above the line, this region, and the green region below that, that is actually G1 plus G2, this 2 and that are equal. In option C, option D, given it is R1 above this is equal to G1 plus G3. So you just add R2 on both sides, that is a G2 on both sides, that is a G2 plus R1 is equal to G1 plus G2 plus G3. It is again 1 by 2. And you can see G2 plus R1 is already what? 1 minus h. So 1 minus h is equal to 1 by 2 implies that h is also what? 1 by 2. So actually a beautiful narrated problem. Simply observing the integral concept and the subdivisions with y is equal to h and suggested regions beautifully with the color and the subdivisions of 4 region, and it is actually very nice and very good problem. Okay. Now, question number 4. Here, f of 0, 1 towards R be a real valid function defined by f of x is root n, so that x belongs to 1 by n plus 1 closed interval plus 1 by n. You know, in this type problem, you want to redefine what is our f of x. Look this. You can see box x is defined like this. If it is n, then n less than or equal to x less than n plus 1. This is the suggestion for that expression. You can see the left values. Then what about this? With this is actually known as greatest integer function. That means if it is 7.3, then integer value is actually what? 7. This is the largest integer which is involved in a given number. At the same time, it is reversingly we can see that's actually least integer function is there, n. Then that n minus 1 less than x less than n. This is. So that n. This up to the right side point. So from that you can see what is the least integer inside them, then you can see the right point can be observed. But unfortunately it is not given exactly in the form, but the reciprocal form is taken. Given root n is suggested with x belongs to 1 by n plus 1 which is closed and 1 by n. Means this x can be included here. Therefore, 1 by n plus 1 less than equal to x less than 1 by n. So reciprocaling it will happen n plus 1 greater than equal to x greater than n. 1 by x. Therefore, n less than 1 by x less than n plus 1. Less than equal to n plus 1. This is a suggestion inside. At the same time, it is actually subtract with one value, that is n minus 1 less than 1 by x minus 1 less than or equal to n. Then you can feel this should be the form of a least integer function as 1 by x minus 1 correspond to n. This f of x is equal to n, then we can see that. But it is given as root n. Then what is our f of x? F of x is equal to square root of 1 by x minus 1. This is actually the expression. But you can see, then it is moving up and down. The next value is actually what? This is actually, we can see, whenever we think about that for all x inside them, root of 1 by x minus 1 is less than f of x less than next value is root 1 by x. This. Whatever may be this one, x is moving from cross interval n plus 1 to n, next integer. You can see, if it is a root value should be an integer, then the other integer should be there. This is the expression in this condition. So, at the same time, there is one more inequality which is given as a g of x. But inside that g of x, there are some integral sign. Given x belongs to 0, 1, that means only positive, no need of left side, limit extending the 0 means only what? Right value is towards 0. No need of our left side interval. Okay. So, x belongs to 0 to 1. Our g of x is defined like this. Less than 2 root x. And here it is less than integral x square to x root of 1 minus t divided by t into dt. This is our g of x. Now your requirement is a limiting case. Our requirement is limit x tending to 0. That's actually 0 plus unit is there. F of x into g of x. I think that it is very difficult to observing this expression and that. Then we can use our skews theorem can be useful or fruitful here. What about that? We can identify two expressions. Suppose h of x is less than f of x into g of x less than or equal to some k of x. There are two different functions. And you are thinking the limit inside there. There is a limit x tending to 0, h of x is less than limit x tending to 0, f of x into g of x less than limit x tending to 0, k of x. Look this, there are two different inequality and both of them are tending towards them. You can keep the balancing expression one. Right side expression of g of x should be multiplied on right and left should be here. You can see that is very important situation to making the inequalities in proper pattern like this. You want to applying this expression here, and here f of x is also an inequality inside them. So the balancing condition should be there. You just multiplying the right side with the left side of the inequality and the left side with the right side of inequality to balancing this limit inside. That means your h of x limit x tending to 0, h of x is equal to limit x tending to 0 integral x square into x root of 1 minus t divided by t dt into our f of x. You should multiply with 1 by root x, this expression, and our right side, that is limit x tending to 0 on the right side expression, that is k of x is limit x tending to 0, 2 root x is given into that root x. Sorry, not root x there. On the left side is actually this root of 1 minus x by 1. This. Now you just find what about the limit in the both the case. You can see these two limits are either side of f of x into g of x. Then that f of x lies between that 2 and g of x is also, that should be here. Whenever you can think about the skews theorem is there, when the situation, you can just multiply like this. Here it is and that it is, then like this one. So whenever you can take the product, it is better right side to left and left side to right, then we can see the intersecting values inside there. This is the reason you can left and right is applied to choose the multiplication inside there. Now how to find the limit of the this expression? Here, this is limit x tending to 0, integral x square to x, root of 1 minus t divided by t into dt, all divided by root x. You can see when extending to 0, this is x square is also 0, the limit also, upper limit also 0. So 0 to 0 is actually what? 0. Whatever may be the expression, that will be 0. And denominator is also 0, so 0 by 0 form. When it is 0 by 0 form, you are able to apply L'Hopital rule. That means we can differentiating as limits x tending to 0. How to applying the Leibniz rule for finding this limit? X is applied here as a square root of 1 minus x by x into 1 minus a root of 1 minus x square by x square into 2x, all divided by 1 by 2 root x. Here we are applying both L'Hopital rule and the Leibniz rule for a definite integral as the derivative. Then you can see this is equal limit to limit x tending to 0, this become reciprocal 2 root x into, this is actually a root 1 minus x by root x minus, this is root 1 minus x square divided by x into 2x. So we can cancel this 2. Now expand, it is equal limit x tending to 0. When you multiplying here, root x get cancelled, it is a 2 into root of 1 minus x minus that 4 root x into root 1 minus x square s. Now we can apply 0, this 1 minus 0 is 1, so 2 into 1, 2, and here it is 0, so that's totally out, you got 2. And what about the right side? Or k of x, limit x tending to 0, k of x is equal to limit x tending to 0, 2 root x into a root of 1 by x minus 1, which is equal limit x tending to 0, 2 root x into root 1 minus x divided by root x. So this to be cancelled. When x tending to 0, this is 0, and 1 into root 1 becomes 2. Means limit x tending to 0, that f of x, g of x, right side also 2 and left side also 2. By skews theorem, that is tending to 2, and that is our required answer. Okay. This is another beautiful problem. Finally, you want to find a maximum value of distance between two lines L1 and L2, where L1 is the main diagonals of the cuboid, not cuboid, it is a cube. But L2R is also diagonal, not on the main diagonals of the cube, but the diagonals of the side faces of the cube. So, first of all, you can make the values of that vertices in terms of our 0 and 1. Then it is better we can draw this. You can see this is our origin 0. So, we can mark origin is 0, 0, 0. Now, we can choose one vertex A is there and whose coordinate is 1, 0, 0. Then it is our x-axis. And here we refer it as a y-axis, and there is another point B is there. It is actually 0, 1, 0, and C is our z-axis 0, 0, 1. So this is actually, origin and A 1, 0, 0, and like this. Now we can see, I just draw this side and this side, and here also another one, and come back to this. So you got the cuboid. Now look this. This we refer as O dash. That's actually just opposite of O. O is 0, 0, 0. Then O dash is simply, you can choose it as 1 unit each. So it is 1, 1, 1. So you can see the complement of 0 is 1. Likewise, we can see this is O dash, and O dash is the diagonal. You can see the diagonal. So what is O dash? O dash is equal to I plus j plus k. Just you subtract that too. Likewise, you can see if A is 1, 0, 0, then what is A dash? This becomes 0, 1, 1. This is the best way to remember the form. This A and here it is A dash. So B, then that point is B dash. B is a 0, 1, 0, then that B dash is a 1, 0, 1. And C, then this point is C dash, that is equal to 1, 1, 0. This is the best form. Now, you can see like that O dash, A dash, B dash and C dash are 4 different main diagonals through inside the cube. At the same time, you can see, suppose I just take this O dash is this. Look this, that O is here, the vertex, and other vertex is there. You can see with other diagonals A dash and B dash etc. are intersecting to O dash, so shortest distance are 0. At the same time, if you draw this side is also intersecting, then SD is equal to 0. So that expression is there, but while you draw this one, like this and this one, that means there exists a diagonal and our main diagonal will make maximum shortest distance, and each and every faces that should be exactly same. All other diagonals definitely intersect and the shortest distance is 0. So our question, what is the maximum value of the shortest distance between the one of the diagonal on the face and any other diagonal here? O dash, and this it's actually C dash is here and B dash is there. So C dash B dash. This line and that line will make the maximum shortest distance. All other shortest distance are 0. So you just find what is equation of O dash. Equation of O dash. You can see O is an origin and O dash is length 1, 1, 1. So this implies that x minus 0 by 1 equal to y minus 0 by 1 equal to z minus 0 by 1. And equation of C dash B dash. You know C dash is 1, 1, 0. That is actually x minus 1 divided by B dash is, we can write down the point as C dash is equal to 1, 1, 0 and B dash is equal to 1, 0, 1. So x minus 1 divided by 1 minus 1 is equal to y minus 1 divided by 0 minus 1 is equal to z minus 0 by 0 minus 1. This is equal to x minus 1 divided by 0, y minus 1 by minus 1 and z minus 0 divided by minus 1. So you can see, what about the value for shortest distance? SD. How to find SD? The formula for SD is equal to A2 bar minus A1 bar dot B1 cross B2 all divided by B1 cross B2, and choose the magnitude of it. This is the shortest distance. Here the first vector give you A1. A1 is 0, 0, 0 and A2 is equal to this value 1, 1, 0, which implies A2 bar minus A1 bar is equal to 1, 1, 0. This is actually A2 bar minus A1 bar. Now you want to find B1 cross B2. B1 cross B2 is equal to determinant I, J, K. B1 is initially this 1, 1, 1 and next is 0, minus 1, minus 1. which is equal to I into 1 minus minus 1 minus j into 1 minus 0 plus a k into minus 1 minus 0 will be 2i minus j and minus k. That is actually b1 cross b2. So what is mod b1 cross b2? Is equal to root of 4 plus 1 plus 1, that is root 6. So you already observe them. Shortest distance is equal to a2 bar minus a1 bar. That is actually I plus j plus 0k dot. This 2i minus j minus k divided by this value, root of that 6. That is equal to 2 minus 1 plus 0 divided by root 6 is equal to 1 by root 6. You know, any such two diagonals be selected, the shortest distance we can observe it as what? 1 by root 6. Otherwise it is 0. So there are two different values, either 0 or 1 by root 6. You are required to find maximum values of the shortest distance. That is actually 1 by root 6, which is given in our option. Now question number 6. Let x is equal to xy belongs to z cross, that's integers. X square by 8 plus y square by 20 less than 1, y square is less than 5. These two are, one is ellipse and other is parabola. You know, this y square by 20 is there, it's actually an ellipse like this. And other parabola is this form. So y square less than 5x. Then three distinct points P, Q and R are randomly chosen from X. Then the probability that PQR form a triangle whose area is positive integer. You know, area using our coordinate may becomes what? Positive or negative. So you can ignore, because of the area that should be positive, definitely we can choose the modulus value. So whether the value should be negative, we can choose the area as what? Positive. But that should be integer. You know, every equation, there is 1 by 2 into b into h is the area for triangle. Area is equal to 1 by 2 into bh. So this product should be an even number. Then only you have an integer area. This is the clue for the problem. But you can select the point which should be interior of this ellipse and that parabola. You can see, when you can put y is equal to 0, this is actually what? Root 8. And when you can put x is equal to 0, this is what? Root 20. So inside that root 20, there is a point here. You can see, solving that too, you can see y square is 5x or x square divided by 8 plus a 5x divided by 20 is less than 1 for this expression. So this becomes 4. You can see x square plus a 2x minus 8 is less than 0. Then you can see this x plus 4 into x minus 2 is less than 0. You can see on the right expression that is out, then x belongs to less than 2. So x is less than 2 and the value for x is less than root 8 and y is less than root 20, like this. So these are the limit of the ordered pair inside. Then you can see in here, this is the line as what? Y is equal to not beyond that 2. That means it is starting from 0, 1, 2 and there. It's actually not y, it's actually x values. So x values are actually up to this 2. Then this value is 2 root 2. So you can see 2 root 2 is there. And if it is more, then it is moving towards this point. So you can see up to the point 1 and 2 can be. There is no need of 0. 0 should be touched here. So x values are less than 3 and more than 0. So the feasible values are 1, 2. So integer satisfying inside them as what? 1 and 2 for x values. But what about y values? Y value we can replace them. You can see maximum is up to 3. But they will not move along the curve. So the feasible value can be observed. These are the 4 values, that is 0, 1, 2 and 3. Among them, you can out this number and that number. So, only we can fix the values are along these 2 lines. These are the feasible integers we can select it. And because of the curve is moving up, you can see the maximum points are here, 1 and 2 here, and here it is 2. At this 3. These are the point above x, and below is also what? Minus 1, minus 2. Here it is minus 1, minus 2 and minus 3. These are the feasible coordinates we can select. So how many such coordinates are there? There are 1, 2, 3, 4, 5. And here 1, 2, 3, 4, 5, 6, 7. So totally there are 5 plus 7, 12 points are there. And they are actually collinear form. How many triangle can be made about them? Or how many points can, not triangle, how many point can be selected as from there? You can see the number of feasible points inside them is selecting any 3 points from it. Among them, how many of them will create the positive region? This is our actual question. So you can, there are totally 12 and you can select the points PQRS, be what? 12C3. So we can see 12C3 is the point. Be the sample space. We are searching the probability. So the sample space of the probability is 12C3, not including that area, but you want to select the point. It is actually specifically given here. 3 distinct points PQR are selected, randomly chosen. Need not be a triangle or on a collinear. So no problem. So you just take 3 points. So the total possibility is what? 12C3. Among them, how many becomes what? The positive integers. That's actually difficult to make the count. Look this. We already think that because of the these 2 lines are parallel, I need to point be selected here from there, 1 point here, 2 points from this. This is first condition. Otherwise 1 point from here and 2. I just mark this one is L1 and this is L2. So we can select 1 point from L1 and feasible points are selected from L2. This is first chance. And at the same time 1 point from L2 and feasible points from the first line. Feasible means 2 points. So how many feasibilities are there? That merely it is best with the counting principle. Look this, and you know the even area. How to find the even area? I just choose this point. And I just mark this triangle. Is it feasible one? No. Because this is 1 unit and here it is 1 unit. So area is what? Is not an integer, 1 by 2. But if you select this one, 2 unit base and this point, definitely it is okay. And if it is 3, no. This selection is not. So if you select a point here, then that 2 point will make an even distance between them. What is even distance? This 2 unit or 4 unit or 6 unit. So you know there are 5 different points. Each and every point can be selected. The feasible 2 points will be satisfactory, whose distance between them should be an even multiple. Then the area is exactly integer. How many such points are there? This is our question. So we can make the count in the form. We can make the count like this. Suppose I selected a point P1 is from the first line. How many sides are there? Look this, there are sides with 2 units. So how many selections are there? I just mark this one is Q1, Q2, Q3, Q1, Q2, Q3, Q4, Q5, Q6 and Q7. They are 7 points. Then look, this one P1 is there. Then we can select 2 points as what? Q1, Q3. This 2. It's actually 2 units. Then we can see this Q2 and Q4 and Q3 and Q5 and Q4 and Q6, Q5 and Q7. These are the feasible unit inside them. 1, 2, 3, 4, 5. So we can see there are 5 such points having 2 units. Now, using that P1, I just take 3 units triangle. Not 3 units, that should be odd number. Definitely it will not work. So 4 units. So 4 unit values are on the side. Then definitely the area is integer. How to find the 4 unit? That is, 1 should be here. 1, 2, 3 and 4. Then that should be Q5. So Q1 and Q5. Then the distance is 4 units. Again Q2. Q2 and Q6 and Q3 and Q7. How many? There are 3. So there are 3 triangles among this P1 will make integer area with a side of 4 unit. Now there is one more chance. 6 unit side should be taken. That means P1 is along with the 6 unit. It's also an even value. How many 6 unit here? 1, 2, 3, 4, 5, 6. Up to Q7. That's actually Q1. So Q1 and Q7 will give the value 6. The suffix difference should be there. This difference, like this. So these are the count. So when you select a point P1, total such triangles are initially 5 plus 3 plus 1 is equal 9. So how many such points on the first line? There are 5. So total triangle should be what? 9 into 5, 45. 9 into 5, that's equal to 45. Now reversingly you can think. There are 7 points. Using 7 points, choose Q1. Then 2 units will be what? P1, this it is P2, P3, P4, P5. Then P1, P3 and P1, P4 and P1, P6. 2 units should be what? 3. And 4 unit, 1, 2, 3 and 4, only one triangle. So each and every point on the second line, there are 7 such points, but you can find 4 triangles from the list out of this line. Will make integer area. So 7 into 4, 28. Already what? 9 into 5, it is 45. So 7 into 4, 28. So the total count is in second line, it is what? 7 into 4. That is equal what? 28. So totally it is 73. So that 73 out of 120 will be the answer. 73 out of 220, option B is there. Okay. So that is a very nice and good problem. Inside them, coordinate system or coordinate section is added and counting situation is there and finally become probability. Okay. Now question number 7. Let P be a point on the parabola y square equal 4x where a is positive. The normal to the parabola at P meet the x-axis at the point Q. Then the area of triangle PFQ where f is the focus of the parabola is 120. If the slope m of the normal and a are both positive integers, then the pair of that a and m. First of all, you can see y square equal 4x is a curve like this. If you choose a point as a 8 square, 280, definitely the normal is not positive form. Then you think about a new point here, 8 square, minus 280. Then you can see this is that coordinate. So t becomes minus t is good for a positive sloped normal inside the problem. So you can keep how to find the equation of normal? You can see any point, equation of any normal is xt plus y is equal to at cube plus 2at. Then its slope is minus t if where t is positive. When t is positive, it is negative here. Then definitely we can see, best we can see this t as actually positive thing. Then we can keep t is equal to minus m and replace the expression, that is minus mx plus y is equal to minus m cube a minus 2ma. This is actually the equation of normal, and we can keep y is equal to mx minus am cube minus 2am be equation of normal with a positive slope, and corresponding point at P is t is minus m, that is am square minus 2am. This is actually P, and focus of the parabola is a comma 0. Then how to find the point on x-axis? It is given. The normal to the parabola P meet the x-axis at Q. Then the coordinate of Q by putting y is equal to 0. Y equal to 0 will give you mx is equal to am cube minus plus 2am. Therefore, x is equal to am square plus 2a. This is x coordinate. So the point Q is am square plus 2a comma 0. And f is a0, and this is actually 2am. So how to find its area? You can see here it is f a comma 0, and here it is q 2a plus am square comma 0. So this distance is what difference between that two number, and there is a point as a p am square minus 2am. So the distance y coordinate is this. Then this is the triangle's area. So you can see the area of triangle is area is equal to modulus of half bh will be 1 by 2 into this area, that is a 2a minus a becomes a plus am square into that minus 2m. This is actually minus 2am. That is the y coordinate inside 284. That should be 120. Now we can consider these two can cancel. You get a square into 1 plus m square into m is actually, you can see 120 is there. Modulus minus n is taken out. Now it is very simple, because you are searching the ordered pair instead of a comma m. What should be the ordered pair satisfying this relation? No need of trying to solve, but you can replace different points which are given to you with different option. Here the first option is 2 comma 3, that is a is 2 and b is 3. What happened to this? You can see 4 into 1 plus 9 into 3. So what is it? 10. 40 into 3. That happy with 120. So this is actually 120. So A3 is the correct answer, and you can see no more ordered pairs are satisfactory with this condition. So just you read, and that's a very simple problem. Question number 8. Here there are two different conditions. That is root of 1 plus 2 cos x is 2 cos square x. The right side is root 2 into tan inverse tan x in this region. So this is actually root 2 into mod cos x. It's equal root 2 into tan inverse tan x. You want to find the possible number of x values in this expression, the number of real solutions satisfactory this equation. So root 2 and root 2 get cancelled. Now we can see this is actually, what is tan inverse of tan x? Tan inverse of tan x will give you a line like this. It's actually minus pi, then 0, then this pi and 2 pi like this. So tan inverse tan x is a parallel strips through 0 all n pi's. And at the same time, what is mod cos x? Cos x modulus sign is actually like this. You can see it is minus pi by 2 and that is pi by 2 and 3 pi by 2, etc. So, among that, here you can see pi by 2 is here and this. So, first section like this and section second like this and here also that. So, you want to find a count which is satisfying the equation. In minus 3 pi by 2, minus pi by 2, that is actually 1 point and then one more point and one more point. So, there are 3 different x will satisfying the given equation. So, number of solutions is 3. Question number 9. Best you can draw this piecewise expression using the graph. You can see our x values and f of x. First of all, you can see x becomes 0. Then it is actually n. If you are replacing x 0 here, then this become out and only n. Now you put x is 1 by 2n. When you replace x is 1 by 2n, this 2n get cancelled 1 minus 1, 0. So n into 0, 0. So next 1 by 2n is input and correspondingly 0 is there. Here also you can put 2n, you can see 1 minus 1, 0. So it is continuous and we can draw that values here. So then you can come to the next one, say straight line. So you find the other end inside and 3 by 4n. How to find 3 by 4n? 2n into 2n into 3 by 4n minus 1. N and n get cancelled. This to be 2. 3 by 2 minus 1 is 1 by 2. So 2n into 1 by 2 is again n. So next 3 by 4n you got exactly n again. Now you come to this one. Put x is equal to 3 by n you got a 10 and 1 by n. 1 by n is actually 0. So it is 1 by n. It is again 0. And if you replace 1 by n here 0 and that should be 1, then 1 x is 1, n minus 1 get cancelled, got that again 1. So it is actually n. So all these are straight lines because it is first degree equation, it is straight line. Now it is very important situation when you are differentiating, this become minus 2 nx, that is negative, decreasing. Again it is positive, increasing. Negative, decreasing, increasing like this. So the nature of the graph is very important here. You can see whatever it may be 0 to 1, I put it is 1 and when it is 0 you got a 10. I mark this one is n length. Then 1 by 2n, this 1 by 2n, then 0 is actually decreasing. So this is the curve, straight line. Then next one is 3 by 4n and it is increasing up to n, this. Then 0, then n, this. This is the curve, maximum 1 and decreasing, increasing like this. Now I complete this expression up to 1 and this is actually 1 by n. Now I read continually this one. If n is such that area of region bounded by x is equal to 0, x is equal to 1 and y equal to 0 and y equal to f of x, this region. So the required region is this region is 4. Then what is the maximum f? That f. What is the maximum f? You can see maximum f is actually n. So your requirement is what is n? If the area is 4 unit, what is n? So it is actually a very simple question. You can see what about this height? It is n. then this length is 1 by 2n. So this is a small triangle. Area is equal to 1 by 2 into this is 1 by 2n into n. Plus here it is a 1 by 2 into this 1 by n minus 1 by 2n, this into n. Plus again 1 by 2 into 1 minus 1 by n into n. That is equal to 4 is equal to, we can cancel this to, it is 1 by 4 plus 1 by 4 this n get cancelled after it is 1 by 4 plus finally it is equal to n minus 1 by 2. So it is equal to 1 by 2 plus n minus 1 by 2. So just you multiplying with the 2, it will give you 8 is equal to 1 plus n minus 1 implies n is equal to 8. So the maximum value of the function is 8. Your requirement is n, and that should be the maximum value of the function. This is also a very simple question. Now question number 10. It's actually a good problem. Here it is given as there are r 5's in between 7 and 7, that is 7, 5, 5, 5, etc. up to 5, and here 7. That's actually it is given as r. So totally this number and that number will become what? R plus 2 digits in the entire group. That means if it is 10, then totally there are 12 digit number. If there are 10 5's, then 12 digit number is there. So come back to simplifying initially our S. S is equal to 77. This will be written as 7 into 10 plus 7. And next term 7 5 7. That is equal to 7 into 100 plus 50 plus 7. This will be written as in the form 7 into 10 raised to 1 plus 50 into 0 plus 7 into 1. Here it is equal to 7 into 10 raised to 2 plus 50 into 1 plus 7 into 1. Next 7 5 5 7, that is equal to 7 into 10 cube plus 50 into 11 plus 7. So 7 triple 5. 7 is equal to 7 into 10 raised to 4 plus 50 into 111 plus 7. So we can take the entire sum as S will be, we can add this all terms are 7 into 10 plus 7 into 10 square plus etc. plus 7 into 10 raised to 99. Because there are 98 terms are with the 5 terms. So 7 with the 99 zeros will be following up, still become what? 7 into 10 raised to 99. And after we can see plus 50, we can chosen out, it should be 1 plus 11 plus etc. up to a number 1 1 etc. 98 plus 7 into 99. This is actually our expansion. Now we can simplify this by choosing 7 as a common factor. 10 plus 10 square plus etc. plus 10 raised to 99 plus 50 by 9 into 9 plus 99 plus etc. plus 9 9 etc. 9 9. These are 98 times plus 7 into 99. Now we can simplify this by adding a 1 here as in the form 1 plus 10 plus etc. plus 10 raised to 99 minus 1 plus 50 by 9 into 10 plus 10 square ten minus 1 in plus 10 square minus 1 plus etc. plus 10 raised to 98 minus 1 plus 7 into 99. This we can draw 7 into 10 raised to 100 minus 1 by 9 minus 1 plus 50 by 9 into this also we can transform the form 10 plus 10 square plus etc. plus 10 raised to 98 minus 98 ones plus 7 into 98, 99. This we can draw 7 into 10 raised to 100 minus 10 divided by 9 plus 50 by 9 into this is again 1 plus 10 plus etc. plus 10 raised to 98 minus 99 plus 7 into 99. It is equal to 7 into 10 raised to 100 by 9 minus 70 by 9 plus 50 by 9 into this will be 1, 1 etc. 1 with 9, 99 ones are there minus when you multiplying this it is become 550 and this 99 into 7 is equal to 693. So this is equal to 7 into 10 raised to 100 plus 50 into 1, 1 etc. 1 up to 99 times minus 70 all divided by 9 plus the difference of 693 and 550 is equal to 3, 4 and 1. So 143. So 143 into 9 that's equal to 7 into 10 raised to 100 plus minus 70 plus 1287. All by 9. It is equal to 7 into 10 raised to 1000, 10 raised to 100 plus 5, 5 etc. 5, 0 plus 1, 2, 1, 7 all divided by 9. If you subtract that 70 from here, this here, then we can choose it is equal to in the form 7 into 10 raised to 100 plus 5, 5 etc. 5, 0 plus 1, 7 can be taken and 1, 2, 1, 0 all divided by 9. Now, this number can be clubbed as, there are 99 5s along with the 700, this becomes 7, 5, 5, etc. 5 with the last 7 is there, and here it is 99 plus 1210 all divided by 9. This is actually given as our S. Then given expression which is given as in the form 7, 5, 5, etc. 5, 7, this number should be 99 plus m divided by n. Comparing these two, we can see m is equal to 1210 and n is equal to 9. So take the sum, m plus n is equal to 1219. Okay, now question number 11. It's actually a very simple problem. A contains exactly one positive integer n. You can see A is equal to a number 1967 plus 1686 I sin theta divided by 7 minus 3 I cos theta, where theta belongs to a real number. So look here, you just find any number, it should be common with that 197, 1967 and 1686. You think about this number. First of all, we can factorize this by dividing by 7. So 1967 divided by 7 will give you 2 times here, 14, 8, 7, that is actually 1. So this number is 281 into 7. What about this number? 1686 divided by 2. So 8, 4, 3. Then we can divide by 3. That is equal to 281. Look this, there is a 281 be a common expression here. So both these two number, there is a number we can chosen out as 281. So 281 into 7 plus 6i sin theta divided by 7 minus 3i cos theta. Look this. A contains exactly one positive integer n. So correspondingly this number should be one positive integer. What is that positive integer? This is our question. You can see easily it is a 281 be a common factor. And these two numbers are there with our common form. You know, this number exists with I, definitely it will not work because it is a complex number. Whenever you want to find the integer, this part should be out. So if it is remove the form, definitely that should be a multiple of 1. You can see this will happen with the positive alias. When you multiply with the conjugate and simplify them, you get a tan theta is 1 by 2 minus 1 by 2. Then we can convert them as sin and cos. We can find the integer part inside them, but no need of that. And we can see this expression will provide you the maximum value should be 1 because the integer values are this. So the integral values exactly inside them is 281. That should be the integer values. Otherwise, you can expand the form by multiplying with the conjugate and we can put the imaginary part should be 0. Then you can see that tan theta is minus 1 by 2. Correspondingly, we can find sin and cos inside them and replacing that sin and cos in the rest residue inside them and check about the integer part inside them will give you the correct answer. So, exactly the answer is 281. Now, question number 12. You can see here there is a plane and alpha square plus beta square plus gamma square is 1. Implies this is actually a unit vector. Suppose by different values of alpha, beta, gamma, we can see this is a unit vector means our any point as a vector u bar and v bar is there, then u bar, v bar and w bar are unit vectors because they are correspondingly alpha, beta, gamma and alpha square plus beta square plus gamma square is the direction cosines. So definitely U, B, C are unit vectors. Then what about the modulus? You know, mod U bar minus V bar, the whole square is equal to U square plus V square minus T U dot V. You can see this one and minus 2 into U bar dot V bar. It is exactly same with the nest and nest. So we can see this, the second section is also 1 plus 1 minus 2 V dot W and 1 plus 1 minus 2 W dot U are this. Means these are equal means what? U dot V is equal to V dot W is equal to W dot U. These are the expression. Suppose this is actually equal quantity, we can keep that number a constant k. You don't know that number, but we can keep it as k. Box of U, V, W the whole square is equal to U dot U, U dot V, U dot W like this. And next V dot U, V dot V and V dot W and W dot U, W dot V and W dot W is the values of the square inside the box series. And this value as per the condition it is equal to 1 K, K, I choose that values is K. So again next K, 1, 1 and K, K, 1 is the value. So its root will be the volume of our tetrahedron and dividing by 6 will give the answer correspondingly there. So what about the answer for this determinant? We can see when you add this all and 2k plus 1 can be taken out, then rest will become 1k, k and 1 and k this, and here it is 1k and 1. 2k plus 1 into k square minus 1. We can subtract this one from here and choose the determinant value should be in the form the whole square form, this. So box of U, V, W is equal to k minus 1 into root of 2k plus 1. So the problem finished by finding the value for the k, that is actually U dot V. We can see that U dot V are three vectors in the space, the form. These are, actually it is U bar, we can see it is A, and here there is a point V bar, and that is we referred as B, and here it is C bar, we referred as our W, this. But they are modulus value them, definitely this will be a unit circle, that U minus V and V minus W and W minus U are what? Equal. So this is actually unit triangle. So we can see this is an ABCB, an equilateral triangle. You want to find the length that U minus V. How to find this length? That actually it is difficult to find. But we can. There's one more condition. There is a straight line, sorry, a plane, it is root 3x plus 2y plus 3z minus 16 equals 0 is given. And from that, it is given the distance from any point of that A, any point from this B, same means it should be parallel to that ABC. So definitely we can see, suppose from A, we can see this length from origin. This is actually a plane, and there is a point A, origin is there, and I just find the distance. And you can see the distance from origin to this point is 0 plus 0 plus 0 minus 16 divided by square root of 3 plus 4 plus 9, and with the modulus sign. So you can see it is equal to 16 divided by 4 is equal to 4 unit. So this length is 4 unit, but distance from A is equal to 7 and 2, 7 by 2. So what about this distance? This distance is equal to 4 minus 7 by 2 is equal to 8 minus 7 by 2 is equal to 1 by 2. So this origin to this length is actually what? 1 by 2. Look this, you can see this all A, B and C are on the same unit circle, and this we can see this. So this foot is definitely because of they are on the same circle, this is actually circumcenter. So that circumcenter should made a distance from 1 by 2. And this length is unit 1 unit. So you can see circumcenter and this, that's actually circumference is R. R is equal to square root of 1 minus this 1 by 4. That's equal to root 3 divided by 2. So circumradius of this circle is root 3 by 2. Using that we can find this. You can see inside the circle there is a point A and here it is B and that should be C. From origin this all U, V, W are given as unit, and from that origin this length is 1 by 2. So we can see this radius is root 3 by 2. Now it is very important. You can see if it is a triangle is there, by sine rule this length AB is equal to, or AB divided by sine 60 is equal to R. You know where R is the radius root 3 by 2, that is equal to 2 into root 3 divided by 2, that is equal to root 3. So what is AB? AB is equal to root 3 into sine 60, that is equal to root 3 by 2 is 3 by 2. So this length AB, mod AB, you know, AB is equal to 3 by 2. And OB, it is AB is vector AB is equal to U bar minus V bar. So its magnitude is 3 by 2. So squaring, it will give you U square plus V square minus 2 U dot V is equal to 9 by 4, the square of this number, because you want to find the square. So it is equal to 1 plus 1 minus 2k. You can keep that U dot V is already k. So that k is equal to 9 by 4. Then 2k is equal to 8 minus 9 divided by 4 is minus 1 by 8. So this is the process. You can see there's a line, there's a plane which is root 3x plus 2y plus 3z minus 16 is there. From origin to that plane is make a distance of 4 unit, and from any point to that plane is 7 by 2. This is the argument inside them. So we can find the distance of origin to that ABC plane should be what? 1 by 2. From that we can see the unit circle will provide, or root 3 by 2 will be the radius of it, will give the side of AB. Using that side we can find what is a U dot V or minus 1 by 8. Now come back to the volume. So box UVW is equal to, we can see it is equal to k minus 1 into a root of 2k plus 1. We already defined with a determinant form, that is equal to minus 1 by 8 minus 1 into minus 1 by 4 plus 1, when minus 1 by 8 is applied. So minus 8 by minus 9 by 8 into, here it is equal to 3 by root of 3 by 2. So that's equal to modulus value is taken, then this is equal to 9 root 3 divided by 16. So after finding the values of k as minus 1 by 8, we can see this number UVW, that's a box of UVW is equal to this number. So the volume of parallelepiped V is equal to 9 root 3 divided by 16. So 80V by root 3 is equal to 80 by root 3 into 9 root 3 by 16. So we can cancel root 3 and root 3. This should be 5. So answer 45. Now 13. Let A and B are two non-zero real numbers. The question of x raised to 5 in the expansion of ax square plus 70 by 27b x raised to 4. So we can use our binomial expansion form. So t r plus 1 is equal to ncr a raised to n minus r b raised to r. So it is equal to 4cr into ax square raised to 4 minus r into 70 divided by 27b x the whole raised to r. Which is equal to the form 4cr into a raised to 4 minus r into x raised to 8 minus 2r into 70 raised to r divided by 27 raised to r into b raised to r into x raised to r. So this will become 4cr into a raised to 4 minus r into 70 raised to r divided by 27 raised to r into b raised to r into x raised to 8 minus 3r. Equating this term to the required coefficient of x raised to 4, you got that 8 minus 3r is equal to 4, or it is actually number 5. Then 3r is equal to 3 implies that r equal to 1. So coefficient of x raised to 5 is equal to 4c1 into a cube into 70 divided by 27 into b. Keep it equation number 1. Now you come to the coefficient of x raised to minus 5 in the second expansion. So coefficient of x raised to r or x raised to n inside the second group is 7cr into ax raised to 7 minus r into minus 1 raised to r divided by b raised to r into x raised to 2r. So it is equal to 7cr into a raised to 7 minus r into minus 1 raised to r divided by b raised to r into x raised to 7 minus 3r. Equating this term with the coefficient of x raised to minus 5, we have 7 minus 3r is equal to minus 5, or 3r is equal to 12, then r is equal to 4. Using that 4, it is equal to 7c 4 into a raised to 7 minus 4, that is 3 into minus 1 raised to 4 into divided by b raised to 4. So these two terms are equal. Given it is these two coefficients are equal means 7c4 into a cube divided by b raised to 4 is equal to 4 into a cube into 70 divided by 27 into b. So a cube get cancelled and b is also get cancelled, and it is as in the form 7 into 7c8, that is equal to 7 into 6 into 5 divided by 1 into 2 into 3 is equal to 4 into 70 divided by 27 into b cube. So this we can cancel, and 35 and 2 is there. So it is equal to 27 equal to 8b cube, which implies that 2b is equal to 3. 2b the whole cube is 8b cube, and that should be 27. So 2b is equal to 3 cube, and your requirement is what is 2b. So it's actually a very simple problem. By finding the number of solutions and test the consistency form. You know, the equation can be written in the form x 1 2 1 1 0 alpha 2 minus 3 beta into xy z is equal to 7, 11 and gamma. It is an equation A, x is equal to B form. You can see when determinant A not equal to 0, unique solution. Determinant A equal to 0 and adjoint B 0, then infinitely many solution. Determinant A equal to 0 and adjoint B not equal to 0, no solution. So, as per the comparing options, unique solution, no solution, infinitely many and one more conditions are there. Better we can identifying the concept inside there. But you can see, when you think about the form like this, a new matrix written like this 1, 2, 1, 1, 0 alpha, 2, minus 3 beta, along with the 7, 11 and gamma is taken. Then, if you know, when you simplifying this determinant to reduce the form like this, I just convert the form as subtracting this one from here. You do the same here also. So, I got the same situation as in the form 1, 2, 1 and here it is 7 and 0, minus 2 and alpha minus 1 if you subtract directly, and that should be 4, and here it is equal to how to reduce to this becomes 0 by simplifying the determinant value. You can see this 2 we can subtract by simply twice of this element can be subtracted from here. That is actually R2 or R3 is tending to R3 minus 2R1. Look this, R3 is 2 minus 3 beta and gamma, and this is 2, 4 and 2 and 14. If you subtract what we have 0, that is actually minus 7. Beta minus 2 and it is gamma minus 14. So you got this one is 0 and then minus 7 and beta minus 2 and gamma minus 14. Look this, if you again reduce this expression is 0, then you get a number here and there. If this is not equal to 0, then it is unique solution. Then you can suggest the condition. If this one is 0 and again this value is also 0, then both should be totally 0 and their adjoint is also 0. Then we can find infinitely many solution or like this. So, I come back to reducing this expression is also 0. Look this, R3 is equal to 0 minus 7, beta minus 2 and gamma minus 14. And R2 is equal to 0 minus 2 and alpha minus 1 and 4. Best you can multiply in this situation as reducing this to R0. That I put them multiplying this with 2, it will become 2R3. 2R3 is 0 minus 14, 2 beta minus 4 and 2 gamma minus 28. Again you multiply with the 7. So, 7R2 is equal to 0 and 7 into this is minus 14 and 7 here 7 alpha minus 7 and 28. Now you just subtract, then you get a new R3. That R3 is equal to 0 and 0 and 2 beta minus 7 alpha plus 3. Here 2 gamma minus 56. This is our new matrix form, and we are able to write down finally as this vector or this matrix. What about this? This is in the form 1, 2, 1 and 7 is there, and 0, minus 2, alpha minus 1 and 4, 0, 0, it is 2 beta minus 7 alpha plus 3 and 2 gamma minus 28. Now we have easily interpreted the entire option here. Look this, when this value 2 beta minus 7 alpha plus 3 not equal to 0, then this determinant never becomes 0. Then it is unique solution. That means 2 beta not equal to 7 alpha minus 3 or beta not equal to 1 by 2 into 7 alpha minus 3 will suggest you there is a unique solution. So the condition we can observe there. And when this will be 0, you can see 2 beta is equal to 7 alpha minus 3 or beta is equal to 1 by 2 into 7 alpha minus 3. Then this expression determinant is 0. And you think about them, this column, you can, there exists this 2 and this should be 0 when this will become 56, not 28, it is 256. So gamma is 28 will give the answer, this 0 and here also 0. So there are infinitely many solutions. That means if it is not equal to 28 and this will be equal, there is no solution. These are the options inside them. And among them, there is one more solution we can replace with the given condition where it is gamma 28 and this should be not equal to 0. So we can match the expression. Okay. This is actually a direct question. You can see it is better we can write down the form xi and fi as in order. That means 3, then 5, then next is 4, then you can find this again 4 and 5 is again 4 and then 8 with the 2 and 11, sorry 10 is 2 and 11 is 3. Is in order. Then we can find sigma fi xi and find the mean inside them directly. And if you want to find the median, you just find cumulative frequency. Then half will be included inside and we can find median. And after we can find the mean deviation using the condition and we can connecting that with the variable. So it's also a very simple question. Now question number 16. Here L1 is the line given by 0i plus 0j plus 0k plus lambda into I plus j plus k. This is our R. So this we can retrace in the form x minus 0 by 1 is equal to y minus 0 by 1 is equal to z minus 0 by 1. Similarly, our L2, our second line is actually passes through 0, 1, minus 1. 0, 1, minus 1 and parallel to 1, 0, 1. That is equal to this will x minus 0 divided by 1 is equal to y minus 1 divided by 0 is equal to z plus 1 divided by 1. This is that two line. Now the required plane is what? Is contained this R, but it will make a constant distance with the given line. So there is a line which will make a constant distance, that will be the shortest distance with all points, means that should be parallel to this one. So the required plane is actually contained this line and parallel to the second vector, means you can see the normal of the vector, because it is contained and the plane is parallel to this line also, then this and that cross product will give the normals, that is n bar is equal to determinant I, j, k, that's 1, 1, 1 and 1, 0, 1. This be the normal of the required plane. So we can see it is equal to I into 1 minus 0 minus j into 0 1 minus 1 plus k into 0 minus 1. That is equal to I minus 0j minus k. This is the normal of the required plane, which contain the first vector, means it passes through 0, 0, 0. So the equation of the required plane is x minus 0i plus y minus 0j, which passes through 0, 0 plus z minus 0k dot of this vector, that is I minus 0j minus k is equal to 0, means it is equal to x minus y into 0 minus z equal to 0. That is x minus z equal to 0 is the required plane. Then we can easily find all distance Suppose the first is the distance of the line and this plane. You know, the line contained a point. The second line contained a point 1 minus 1 2. 0 minus 1 1. 0 1 minus 1. So we can find the distance as just replacing that d of h naught from that line is equal to modulus of 0 plus 0 minus minus 1 divided by root of 1 plus 1. That is equal to what? 1 by root 2. Again you can see the next, the distance of that 0 1 2. We can do the same situation. Distance of origin is again 0. So the distance of origin from the point of the intersection with the plane z is equal to c and z is equal to 1. So also we can easily find with the equation and put z is equal to 1 is there. Okay. So we can find this all. Now the last problem, it is actually problems on complex number. It is given initially mod z cube plus a 2z square plus a 4z bar minus 8 equals 0. You want to find the different values of z along with the modulus value. So we can keep, because of this expression, this 8 is real and z bar is also real, choose the complex number, conjugate of it. So taking conjugate, it will become same, z cube itself, but it is 2z bar square plus 4z minus 8 equals 0. This is our first equation and that should be the second equation. Now you subtract, this to be get cancelled because they are same, 8 is also same. Then the difference should be 2 into z square minus z bar square plus 4 into z bar minus z is equal to 0. So we can split the first two times a plus b into a minus b form. So we can choose that 2z minus z bar as a common factor. Then the rest of them becomes z plus z bar minus 2 is equal to 0. This implies that z minus z bar equals 0. You know, this is x plus iy minus x minus iy is equal to 0. Means 2yi is equal to 0 implies that y is equal to 0. You know, given condition inside the imaginary part non-zero, that means what? This will not be satisfactory. So only this condition is satisfied. That is imagine for y not equal to 0 can be accepted. So first will not work, and second is x plus iy plus x minus iy minus 2 is equal to 0. Therefore 2x is equal to 2 implies that x is equal to 1. So as per of that imaginary part not becomes 0, and this condition tells us our result should be whose real part is 1. So we can keep our result z is equal to x plus iy, then x is equal to 1 and y not equal to 0. Keep y is equal to lambda and lambda not equal to 0. Then what happened that our z, therefore z is equal to, z is equal to 1 plus lambda I. Then what is mod z? Mod z is equal to root of 1 plus lambda square, and z square is equal to 1 minus lambda square plus 2 lambda I, and z bar is equal to 1 minus lambda I. These are the conditions of the given expression, and we can solve for lambda. Given it is z cube, mod z cube plus 2 z square minus plus 4 z bar minus 8 equals 0. So we can keep this one as 1 plus lambda square the whole raised to 3 by 2 plus 2 into z square be written as in the form 1 minus lambda square plus 2 lambda I plus 4 into 1 minus lambda I minus 8 equals 0. That is equal to 1 plus lambda square raised to 3 by 2 plus 2 minus 2 lambda square plus 4 lambda I plus 4 minus 4 lambda I minus 8 equals 0. So this lambda I part get cancelled, and this will become 1 plus lambda square the whole raised to 3 by 2 plus minus 2 lambda square minus 2 is equal to 0. That is equal to 1 plus lambda square into root of 1 plus lambda square minus 2 into lambda square plus 1 is equal to 0. So, you know, lambda square plus 1 not equal to 0. So, this will give you root 1 plus lambda square is equal to 2, or this implies that 1 plus lambda square is equal to 4, or lambda square is equal to 3. Lambda square 3 means mod z square. So, mod z square is equal to 1 plus lambda square is equal to 4, because lambda square is 3. So, mod z square is for option 2. And z minus z bar the whole square. What is z minus z bar? Z minus z bar the whole square is 1 plus lambda I minus 1 minus lambda I the whole square. It is equal to 1 get cancelled, is 4 lambda square, that is equal to 12. I square is 1. And next, mod z square plus z bar the whole square. We can see that all mod z square plus z plus z bar the whole square, it is equal to mod z square is already 4 plus this is actually 1 plus lambda I plus 1 minus lambda I the whole square get cancelled, is 2 square 4, this is 8. And mod z plus 1 the whole square. Mod z plus 1 the whole square is equal to 1 plus lambda I plus 1 the whole square. So, it is equal to 2 plus lambda I mod the whole square, that is equal to 4 plus lambda square is equal to 7, because lambda square is 3. So, that all options are given. This was a very simple question. Thank you, dear all students.